Somewhere in a bathroom mirror right now, someone is looking at a freckle, or a farmer's tan, or the pale strip of skin under a watch strap they never take off. Nobody thinks about it for more than a second. It's just skin. It's just color. It's the wallpaper you were born in. But that wallpaper has a paper trail, and the paper trail leads back roughly 300,000 years to one place, one population, one single shared starting point for every human being who has ever lived. Here's the part that breaks people's brains a little. Go back far enough, and there is no light skin. None. Not a little. Not rare. Zero. Every ancestor of every person on Earth today, every king, every peasant, every Viking, every Scandinavian, every redhead, comes from a population that was dark-skinned. Full stop. The lightest skin tone that has ever existed in this species didn't show up until an evolutionary blink ago. Which means the question isn't really, why are some people light-skinned? The real question is stranger. What in the world happened to change something that used to be true for 100% of us? Quick detour before we get there, because you need to understand what skin is actually doing before any of this makes sense. You've probably never thought of your skin as a piece of equipment. It's easier to think of it as a container, the bag your organs live in. But skin is an organ in its own right, the biggest one you have, and it runs a full-time defense operation you never signed up for and never get a day off from. One of its jobs, arguably the job, is standing between you and ultraviolet radiation. UV isn't some vague bad-for-you thing your dermatologist mentions. It's radiation that physically tears apart chemical bonds. It shreds DNA. And DNA that gets shredded in the wrong spot, enough times and in the wrong way, becomes cancer. This is where melanin walks on stage. Melanin is the pigment that makes skin darker, and biologically speaking, it is a sunscreen that grew inside your body. More melanin means more of that incoming radiation gets absorbed before it ever reaches the DNA sitting underneath. Less melanin, less protection. So, under the punishing near vertical sun of equatorial Africa, where this whole species got its start, dark skin wasn't a preference, it was armor. Evolution doesn't hand out participation trophies. It runs one brutal test over and over on every single trait. Does this help you live long enough to make more humans? In Africa, under that sun, dark skin passed that test every single time. Here's the thing nobody puts in the highlight reel of this story, though. The sun wasn't just coming for your skin cells. It was coming for something far more fragile, something living inside you that most people have never even heard of. It's called folate. It's a B vitamin. It's floating in your bloodstream right now doing quiet maintenance work. And if you're pregnant or about to be, it becomes one of the most important molecules in your entire body. Folate is essential for closing the neural tube in a developing embryo, the structure that eventually becomes the brain and spinal cord. Not enough folate in those first few critical weeks, and that structure can fail to close. The result isn't a minor inconvenience, it's a severe birth defect. It's a miscarriage. And UV light destroys folate, burns right through it. So picture a population living unclothed under that African sun with thin, low melanin skin. Their folate is getting cooked in real time. Their pregnancies are failing at higher rates, and their genes simply don't make it to the next generation as often. So now you've got two separate systems both screaming the same instruction. One, protect the DNA from cancer. Two, protect the folate for the next generation. Two completely different biological emergencies, one identical solution. Dark skin wasn't just useful in Africa, it was closer to mandatory, which makes what happens next genuinely strange. If dark skin is this 2-for-1 survival package, field-tested for hundreds of thousands of years, why isn't everyone still dark-skinned? Somewhere between 70,000 and 100,000 years ago, small groups of humans started drifting out of Africa. Nobody packed a bag and announced a migration. It was slower and quieter than that. A group moves a little farther than their parents did, their kids move a little farther still, and over enough centuries the species spreads itself across the Middle East, into Europe, deep into Asia, and eventually across into the Americas. And the further north people drifted, the weaker the sun got. Not literally, the sun didn't change, but at higher latitudes, sunlight comes in at a shallower angle and has to punch through more atmosphere to reach you. Winters stretch longer, skies stay gray for months. The UV environment in, say, southern Scandinavia is almost a different planet compared to equatorial Africa, and that's where the armor became a liability. Not because of cancer, UV was so weak up north that cancer risk dropped off dramatically. Not because of folate either. Less UV meant less folate destruction, so that threat basically evaporated. The problem was something else. Something that barely gets mentioned when people tell this story, and it deserves way more credit than it gets. Vitamin D. Your skin makes vitamin D using UVB light as the raw ingredient. It's less organ and more solar panel. And vitamin D isn't optional. It's the reason your gut can absorb calcium at all. No vitamin D, no calcium absorption, no matter how much of either you eat. No calcium, no properly built bone. In children, that shows up as rickets, bowed legs, a flattened skull, and stunted growth. In adult women, it shows up as softened pelvic bones, and softened pelvic bones make childbirth dramatically more dangerous, sometimes fatally so. So take a population with beautifully efficient, deeply protective melanin, perfect for Africa, and drop them into a gray northern winter with barely any usable UV. Their skin doesn't know the difference. It just keeps blocking, exactly like it's designed. Except now there's nothing dangerous left to block, only vitamin D they desperately need and can't make. Bones weaken, births get more dangerous, fewer children survive to have children of their own. In a world with no supplements, no fortified bread, and no daylight lamps, that wasn't a mild disadvantage. It was a slow-motion death sentence, running quietly across dozens of generations. So the mutations that happen to lower melanin production, which show up randomly in any population, stopped being random noise and started being kept. Slightly lighter skin meant slightly more vitamin D, slightly stronger bones, and slightly safer births. Generation after generation, the dial nudged lighter. Nobody chose it. Nobody was aiming for a look. It was the same brutal survival math, just running with different inputs. For a long time, the story basically ended there in most textbooks. Humans went north, skin lightened gradually over tens of thousands of years, simple as that. Then ancient DNA blew that timeline apart. The clearest evidence came from a skeleton known as Cheddar Man, a hunter-gatherer who lived in what's now Britain around 10,000 years ago. When researchers sequenced his DNA in 2018, the result didn't match the gradual drift story at all. Cheddar Man had dark to medium dark skin, dark curly hair, and strikingly blue eyes. A combination that looks almost like a costume mix-up to modernize, because we've been trained to pair pale skin with light eyes. 10,000 years ago, that pairing simply didn't exist yet, which means the very fair skin associated with northwestern Europe today, the kind that turns pink after 12 minutes outside in July, is startlingly recent. The genetic evidence points to it spreading widely only in the last 6,000 to 8,000 years. Out of a 300,000-year species history, that's under 3% of the timeline. So what flipped the switch that fast? Agriculture. Somewhere around that same window, populations across Europe abandoned hunting and gathering for farming, and their diet changed overnight in evolutionary terms. Hunter-gatherers had been eating fatty fish, organ meat, and shellfish, foods stacked with dietary vitamin D that had been quietly backing up whatever their skin could produce. Farmers ate grain, wheat, barley, oats. Almost none of it contains vitamin D. That dietary safety net didn't shrink, it disappeared. Suddenly, people were entirely dependent on sunlight-driven skin production for a vitamin their bodies could not survive without, and any skin still holding on to extra melanin was now at a real disadvantage. Add one more accelerant. Farming villages weren't small, scattered bands of 50 people anymore. They were dense, connected, growing populations, and a beneficial mutation spreads through a crowded, networked population far faster than through isolated wanderers. Diet collapse plus population density hit fast forward on a process that had been crawling along for tens of thousands of years and compressed it into a few thousand. And here's a detail that tends to get glossed over completely. There isn't a single light skin gene. Skin color is polygenic, dozens of genes working together to control how much pigment gets made, what kind, and how it's distributed. And when scientists compared the genetic variance behind light skin in Europeans versus East Asians, who also evolved lighter skin independently, they found largely different genes doing the same job. Two separate populations arriving at the same solution through completely different genetic paths. That's convergent evolution. And when evolution reinvents the same answer more than once from scratch, that's about as strong a signal as biology gives you that the pressure behind it was real. Blue eyes have their own even stranger footnote. Every blue-eyed person alive today traces back to a single shared mutation in a single individual, somewhere near the Black Sea, sometime in roughly the last 6,000 to 10,000 years. Before that person existed, there were no blue eyes anywhere on Earth. A trait that feels ancient and permanent is, in the timeline of this species, barely older than the wheel. So here's where all of this actually lands. Skin color was never a hierarchy. It was never a ranking system, an accident, or a matter of taste. At its core, it's a calibration setting, your body's best inherited guess at exactly how much sun protection your ancestors needed based on the latitude they lived at and the food they had access to. Dark skin isn't the primitive version, and light skin isn't the advanced upgrade. Dark skin is the default setting this entire species launched with. Everything lighter than that is a later patch written by specific environments solving specific problems. The same sun pushed one population toward more protection and another population toward less, using the exact same tool, melanin, for opposite jobs in opposite places. It never picked a side. It was never trying to. It just kept radiating indifferent as ever and let a few 100,000 years of biology sort out the rest. We built entire hierarchies, entire justifications for cruelty on top of what is, underneath it all, a vitamin D problem and a folate problem wearing different clothes. So next time you catch your reflection under bad bathroom lighting, that shade staring back at you isn't random and it isn't final. It's a record, a working document your ancestors kept one generation at a time of exactly how much sun they could survive.